Hello. So, now we'll be talking mainly about again interprocess communication with a shared data structure, a common data structure shared between more than one process. So, as an example perspective, the program that I will be demonstrating is containing a parent process and a child process, and both of them would be sharing a circular queue. Now, here, like in this particular program, I have used different functions and system calls. Mainly we know few of them. Rather, we already used fork system call. So as we know, fork would be used for creating child process, duplicating the calling process. One another function call or system call that I would be using is shm open. Now this shm open call would be used to rather create or open or even unlink, like shm unlink also would be there as an part of our code. It would be used for opening or creating a shared memory object. And like as a return value perspective, it returns the file descriptor which can be used to reference the shared memory. Now what happens, like in our code, the parent process would be calling shared memory open shm open to create a shared memory object, and in child process we would be giving access to this shared memory using the same name. So we have to add one name here, like which is our first parameter, constant character name. And while we talk about using this descriptor in child, would be making use of this name again. So let me open the code. So I will open the code, as well as I will talk about different function calls or system calls used there. Gedit. Okay, so initial part, like I would be having like header files included, which actually are talking about or addressing the functions which we have used over here. So if I try to go talk about the main program where I am giving call to shm open with the shm fd integer, like as I stated there, creates and opens a new or opens an existing shared memory object. So we created this object and we have given name to it as myQSHM. Fine. Now this would be a name of our shared object, and we are giving permission as ocreate and ordwr. So this the creation of object, if it doesn't exist, create would be used, and opens it for reading and writing. That's what this particular flag exactly addresses. Now you will see that I have used permission again, like as an octal number 0666. So this sets the permission for read or read and write for everyone. Then I have used a function called ftruncate. Now this ftruncate function would be used to resize a file, okay, or a shared memory object. Now you may see, like I have added that file descriptor there. So if I open ftruncate, so this F truncate text and file descriptor. Truncate would be taking file path, but here as we are using file descriptor, so that's why F truncate is used, which resizes the file or shared memory object to a specific size, and we want that size of that particular object to be this shared data structure called this shared queue. So if I go up and try to see like how my data structure looks like, so my data structure is defined using a type dep, which is a queue of size 5 with respective front and rear added and name given to it as shared queue. So this shared queue is our shared object name. Fine. Now, once F truncate is done, like how it works. So after creating the shared memory, with SHM open, F truncate is called to set the size, and that's what we did. Fine. Now this will ensure that shared memory can hold the shared queue or share queue data structure, which we added as a parameter. Further, like what we are doing, we have to map that data structure with the exact size. Now, how exactly we do? So the mapping would be done of the shared memory object into the address space of the process, which allows both parent and child processes to access the same memory region. Now, like while we use this mmap, okay, this would be used to map the shared memory object into the address space of the process. Now, this mmap allows both parent and child processes to access the same memory region. Now, how exactly we used here is like we are giving call to that mmap to map the shared memory with the file descriptor into a pointer. Okay, like shared queue, we have written as pointer queue. So here, like you give first value to mmap as 0, that is null, because we want the system to choose the memory address. Then we are defining like mmap requires second parameter to be amount of memory to be mapped. So that's why we are giving we are using size of operator, and then we are providing the size. Then prot read and prot write would be allowing read and write access. Further, we will see like there is a map shared. This map shared would be changes in one process are visible to other process, because we want that both the processes to use the shared data structure. Correct. And then we are using file descriptor, which is used by our SHM open earlier. And lastly, like again, we are using 0 because it is an offset for start of the shared memory. Fine. Now further, like if we see when the mapping is done, then front and rear is set to -1 initialization perspective. Now we are giving call to the fork function. Okay. Now this fork function would be fired and child process would be created. Now, if we go to the parent process first, so what we will be doing is like after the child process created. Now, what parent will do, as we are using a circular queue, so parent would be enqueuing elements into the queue. So let us say we are enqueuing here 4 elements 10, 20, 30, 40. Now, what we will do is we will wait till the child finishes. So in child process, so we will start by sleeping with like 1 second. Then actual child process will start dequeuing the elements. Now you will see that I have used here for loop with the 0 to less than 3. That means we want to remove 3 elements from the enqueued elements available in the circular queue. So as an output perspective, like what should happen is it should remove 10, 20, 30. It should wait for 2 more minutes, and then we are exiting from the child. Okay, here. Now, what happens if we don't exit? We will talk about it maybe afterwards. Let us first complete this. Now, as a child finished execution, it will come here. It will wait for 2 more minutes, 2 more seconds rather, and then parent will again start enqueuing. Now, what parent is saying earlier before child before child process terminated, 10, 20, 30 were removed, and in queue now only element remaining is 40. Now I have a parent process adding more elements. So this is printed by us, and then we are enqueuing 2 more elements 50, 60. Now what we are doing in parent, we'll try to dequeue all elements so as to make that data structure empty. So now the elements which would be dequeued would be towards end as 40, 50, 60. And once it is done, like then whatever the shared memory area that data structure we created, we'll try removing that. So the name that will give here is my queue. So let us write there my queue. Let us save this. Okay, we'll close this. Fine. Now let us try to create. Now we already finished execution. So here, like I will execute the code. And here I will try to show you the grep command. Fine. So initially we don't see anything here. So now the child process will start. The parent process execution will start. So right now one can see two. Now when child finishes, only parent is remaining. So you can see that child was removed. So will try to understand the execution now one more time here. Okay, let us execute. So initially 10, 20, 30, 40 are added. Now it goes to child process, dequeues 10, 20, 30. Now remaining element is 40. Now it comes terminate, child terminated. Now parent initialize in queues again 50 and 60. And now after enqueuing is done, we saw that in parent process it will dequeue all remaining elements. That's why 40, 50, 60. Fine. Now what happens if we remove that uh, exit? Okay. So let us see. Emacs. We'll comment that and we'll try to see what exactly happens there. We will not terminate, or because exit system call would be forceful termination. So we'll comment this. Fine. Let us save. Let us come here and we'll try to compile this code again. Okay. Now code compilation is done. Now let us execute here. Now when child finishes, we'll try to concentrate on that part. See, though we haven't exited that time, but child process already completed the execution and it is removed. Correct? Because you can see 2808 and 28 this one was the number 20551 and 20552. So 552 was removed. So if we see the code, let us check. So in child process, child finishes and then terminate. So we will remove this exit system call from here only, and I assume we have return 0. That's why it is removed. Fine. So let us again take the code, compile, and now execute. Correct. So like even if we don't write exit, it is working fine. Fine. Now as child is finishing the execution, parent is still working on that. So child was removed, parent is remaining here because the PIDs also can be seen. And accordingly, like here, what we did is we used a common data structure which is shared between more than one processes, and this is how it works. Now, like other parameters or other functions that we used, one of them was SHM unlink, like towards the end. Like if you see this code, fine. Towards the end, we have used unlink. This unlink is used for deleting the shared memory, and the name shared memory name that we gave is myqueue.shm. Correct. Now, after both processes finish, the shared memory would be uh, deleted, and SHM unlink would be doing that task. So this is how rather like the shared data structure can be seen used between more than one process.